This is an Intel Core i3 540 microprocessor. This cutting-edge technology has poised to revolutionize your computing experience, offering a perfect blend of speed, efficiency, and reliability. Throughout this presentation, we, Group 8, will explore the remarkable features and capabilities of this Core i3 540, showcasing how it can elevate your productivity and take your computing to a new height. So, without further ado, let's embark on this journey into the world of Intel's exceptional processor, the Core i3 540, together with Group 8.
I am Farhan.
Hello, I am Hasif.
I am Zairie.
I am Intan.
I am Syazira.
In this presentation, we will explore its general architecture, including registers, memory, cache organization, the bus system, data transfer mechanisms, the instruction cycle, the arithmetic logic unit (ALU), and the processor pipeline. We will also discuss its application such as the general computing, multimedia playback, light gaming, and office productivity. Let's delve into the capabilities and impact of the first generation Intel Core i3 540 microprocessor. Microprocessors are essential components in computers and electronic devices, providing computing power. Today, we will focus on the Intel Core i3 540 microprocessor. Released in 2010, it belongs to the Clarkdale microarchitecture, a significant advancement from the previous Nehalem architecture. The Clarkdale microarchitecture is a dual-core counterpart of the 22nm Westmere architecture, which is a dry shrink of the 45nm Nehalem architecture. The Core i3 540 emphasizes improved performance and power efficiency, making it ideal for desktop systems. The first generation Intel Core i3 540 CPU is based on the Clarkdale microarchitecture, which is a significant advancement over the previous Nehalem architecture. Clarkdale is a part of the Westmere family, a die shrink of Nehalem, featuring improvement in performance, power efficiency, and integration. Transitioning from Nehalem to Westmere and subsequently Clarkdale represent Intel's continuous effort to enhance performance, power efficiency, and integration in their microprocessors. Die shrink from 45nm to 32nm allows them to improve transistor density and energy efficiency.
Hello, today I will talk about register, memory, and cache organization. The CPU incorporates various types of register, including general purpose register, control register, and segment register. It also includes multiple levels of cache, such as L1 cache, which is instruction and data, L2 cache, and share L3 cache. The memory organization supports DDR3 memory technology too. The first generation Intel Core i3 540 microprocessor features a range of registers to efficiently handle data and instruction. It includes general purpose register for storing temporary data, control register for managing system control and status, and segment register for memory segmentation. In terms of cache organization, the CPU integrates multiple levels of cache, including L1 cache for instruction and data, L2 cache for enhanced performance, and a shared L3 cache for improved efficiency and data access. The memory subsystem supports DDR3 memory technology, allowing for faster data transfer rate and increased overall system performance.
Okay, now I will be presenting about the system bus. So as generally known, system bus is responsible for our microprocessor to connect and communicate with the other part of the system. So there are two types of system bus, which is the local bus and the system bus that connect to the outer part of the CPU, such as the memory and the peripherals, input output modules. So first we will discuss about the local bus. So local bus, for our traditionally Local bus, there are the front side bus which is used traditionally. However, in this architecture, our processor Intel Core i3 550, we use the we introduce the quick path interconnection, which is known as QPI. This QPI will provide higher bandwidth and higher workload. This QPI is replacing the traditional front side bus. Okay, next, the system bus. This is the second bus, the system bus that communicate our CPU to the other outer part of the computer component. So we have like memory, which is RAM, chipset within the motherboard, and peripherals for input-output modules. So first, system bus is divided to three. First is transfer data bus, to transfer data from processor to memory or vice versa. Address bus to specify the direction and the destination of the data, and control signal bus to control data and the address line to control the previous two. So as you can see within the diagram, the Hairiel microarchitecture, which is the first generation microarchitecture, especially more specifically for our processor, which is the Intel Core i3 550. Since this picture show the quad diagram, our processor only have two CPUs, two core CPU. So let's assume there are only two CPU. The interconnection between the CPUs and the other part of the input-output hub, it is connected through the QPI instead of the traditional front-side bus FSB. So, and as we can look that from the CPU, the Hairiel microarchitecture uses the DMI, which is a direct memory interface, to connect with the other part of the computer instead of front-side bus, which is the front-side bus has a lot of bottleneck.
To enable seamless data transfer between the processor and peripherals, the first generation Intel Core i3 CPU integrates supports for several interface standards. The Universal Serial Bus USB interface allows for easy connectivity with a wide range of external devices such as keyboard, mouse, and storage device. The Series LTE SATA interface enables high-speed data transfer to and from hard drive and solid-state drive. Additionally, the Peripheral Component Interconnect Express PCIe interface is utilized for connecting high-performance components like graphic cards, network adapters, and other expansion cards, enabling faster data exchange and enhanced system performance.
Hello, Assalamualaikum. So I will be presenting about the instruction cycle for first generation Intel Core i3 540. So the instruction cycle in the first generation Intel Core i3 540 CPU follows a sequence of stages. Firstly, during the fetch stage, instructions are fetched from memory, preparing them for execution. In the decode stage, the fetch instructions are decoded into micro operations that can be understood by the CPU. The execute stage is where the micro operations are executed, performing arithmetic, logical, or control operations. The memory access stage involves accessing memory to read or write data for the execute operations. Finally, in the write back stage, the result of the operation are written back to the appropriate register or memory location.
Okay, I will now explain about the arithmetic logic unit, which is known as the ALU. So as we know, ALU is responsible for the mathematical operation for our CPU to compute, especially in the area of the arithmetic and logical operation. So for our CPU, which is the Core 500, Core i3 540, it is to it uses the standard arithmetic logic unit. It is able to perform tasks such as addition, subtraction, multiplication, and division and bypass operation. So its ALU is operate in binary data. It able to manipulating and process it according to the instruction, and it is undenied that the ALUs play the most crucial role in executing instruction and performing mathematical computation within our microprocessor. In this case, in the Intel Core i3 550. As you can see, the pictures shows the inside of our processor.
For microprocessor pipeline, the microprocessor utilizes a pipeline architecture to improve instruction throughput. It consists of multiple stages such as instruction fetch, decode, execute, memory access, and write back. By dividing the instruction execution into separate stages, the CPU can work on multiple instructions simultaneously and improving overall performance. The first generation Intel Core i3 540 CPU incorporates a pipeline architecture, which allows for the simultaneous execution of multiple instructions. The pipeline consists of different stages, including instruction fetch, decode, execute, memory access, and write back. By dividing the instruction execution into these stages, the CPU can work on multiple instructions simultaneously, enhancing the overall efficiency and performance of the processor.
I will be presenting about the application of the microprocessor, which I highlight about the desktop computer. So the first generation Intel Core i3 540 microprocessor finds its application in various computing environments. It is well suited for general computing tasks, enabling smooth web browsing, document processing, and multitasking capabilities. With its integrated graphic capabilities, it can handle multimedia playback, including high-definition video and audio. While not designed for intensive gaming, it can handle light gaming and other graphic-related applications. Furthermore, its power efficiency makes it an excellent choice for office productivity and small form factor system.
To conclude, the first generation Intel Core i3 540 microprocessor, part of CapCut microarchitecture, represents a significant advancement in the field of microprocessors. Its general architecture, register and cache organization, bus system, data transfer capabilities, instruction cycle, ALU structure, and microprocessor pipeline contribute to improved performance and efficiency. With a diverse applications, this microprocessor has made a significant impact on computing technology.